Good, so we're continuing with 23 on the same page, the integral from 10 dx, everything divided by x minus 1 and x squared plus 9. Good, so degree at the top is 0, degree in the denominator is 3. We can directly go to step 2. So 10 divided by x minus 1 and x squared plus 9 is, for this factor, it has power 1, so we only have one fraction, plus this one has power 1, but we have bx plus c divided by x squared plus 9 because this is a quadratic factor, which cannot be factored into linear factors with real coefficients. So then again, the top of this fraction is to equal the top of this fraction, assuming we find the least common denominator, of course. So then this will need an x squared plus 9, and of course this will need an x minus 1. So then 10 must be identical with a times x squared plus 9 and plus x minus 1 times bx plus c. We have three coefficients, 3 unknowns, so we need 3 equations. So let's say when x is 0, let's see what happens. 10 equals 9a minus, so this is minus 1 and this is 0, so minus c. Let's see what happens when x is 1. When x is 1, we have 10 on the left-hand side. We have 10a, but this is 1 minus 1, 0, so the whole thing is 0. So from here we know that a equals 1. If a equals 1, 10 minus 9 is 1, so c equals negative 1. So we need one more to determine b. Okay. So let's say x equals negative 1. So let's see what happens with that. So the left-hand side is 10. 1 plus 9, negative 1 is positive 1, plus 9 is 10. So this is again 10a. Here we have negative 1 minus 1, which is negative 2. Negative 1 times b is negative b plus c. So 10 equals 10a plus 2b minus 2c. So I have that c, let me use a different color. I have that c equals negative 1, and I have that a equals 1. So let's find b. So 10 equals 10 plus 2b and plus 2. These two go away, so then b equals negative 1. B equals negative 1, c is also negative 1, and a equals 1. Okay? Here's the equal symbol with the triangle. Jump over all these calculations. And I am going to write in here the integral from a, 1 over x minus 1 dx. Both b and c are negative 1, so I'm going to pull it out. So x plus 1 over x squared plus 9 dx. Good. I'm going to move this out of the way. So this is definitely the absolute value of natural log of the absolute value of x minus 1. In this situation, we will separate into two fractions. The integral from x dx over x squared plus 9 minus the integral from dx over x squared plus 9. I'm going to work on the side on each and every one of these two separately. So here, for this one, we're going to say let u be x squared plus 9. We're going to use a simple substitution, and du equals 2x dx. No problem. Remember how I like to do it. If it's just a simple number, it's so easy. So this part will be negative 1/2. The integral from du over u, which is negative 1/2. And it will be natural log of u. But u is x squared plus 9. It does not need absolute value. X squared plus 9 is always positive. So we have this done. Now we have this piece done. Now let's work on that. Yes, you can use the table for this one, but I want to show it again. So the integral from dx over x squared plus 9. You have several options here. You can use the substitution, which in this case will be tangent squared plus 1. You have to factor out 9. So let's do that. So 1 over 9, the integral from dx, and this is x over 3, everything squared plus 1. And x over 3 is denoted by tangent theta, or x equals 3 tangent theta, and dx equals 3 secant squared theta d theta. So this will be 1 over 9, the integral from dx, 3 secant squared theta d theta, divided by, as we know, tangent squared plus 1 is secant squared. Gone. So this is 1/9 with 3 in front, so 1/3. So I'm going to put here the equal symbol and a square, rectangle, maybe. Okay, so 1/3, the integral from d theta. So this is 1/3 theta plus a constant c, and of course here plus a constant c, but we're going to put only 1. So, but what is theta? I apply arc tangent to both sides. So this is 1/3 arc tangent x over 3 plus a constant c. So I have now the final. So I'm coming back here, different color, maybe green. Okay. Jump over all these calculations to get the final answer. Okay, so we already had natural log of x minus 1. We determined the second one, which was a -1/2 natural log of x squared plus 9. And there was a minus in front. Don't forget the minus, so I have to put a minus here. -1/3 arctangent x over 3 plus a constant c. And that is done. Okay, let's look at one more. Something like 21. 21 has the integral from dt over t squared minus 1 squared. And notice that here we have two factors, right? We have t plus 1 and t minus 1, and both of them will have power 2. So this is the integral from dt over t plus 1 squared, t minus 1 squared. There is no step 1 here. The degree of the numerator is much smaller, is 0 versus degree 4 in the denominator. So we can directly move on to partial fraction decomposition. Two factors, 2 plus 1 and then 2 plus 1 squared. Another one, t plus 1, t plus 1 squared, and then t minus 1 and t minus 1 squared. So this is 1 over t plus 1 squared, t minus 1 squared, which reduces to a, or decomposes into a over t plus 1 plus b over t plus 1 squared plus c over t minus 1. I don't need parentheses, but if I put it here, I'm going to put it here too. And d over t minus 1 squared. Why all of these have no x or no t in them? It's because all these are linear factors, not quadratic factors. Okay, so now what would be the adjustments? Okay, this one needs a t plus 1, but also a t minus 1 squared. This one only needs t minus 1 squared. This one needs a t plus 1 squared and also a t minus 1. And this one only needs a t plus 1 squared. Okay. So then 1 must equal a t plus 1 t minus 1 squared plus b t minus 1 squared plus c t plus 1 squared t minus 1 and plus d t plus 1 squared. Okay. Okay, that's page 7. So let's see what we can do. First, I'm going to start with t equals 1. So we have 1, 2, 3, 4 unknowns. We need 4 equations. So I'm going to start with t equals negative 1. When t equals negative 1, this term, and this term are all 0. So 1 on the left-hand side, negative 1 minus 1 is negative 2. Negative 2 squared is 4. So 4b. So we already have b equals 1/4. When t equals 1, if t equals 1, then this term and this term and this term will be 0. And 1 plus 1 is 2. 2 squared is 4. So 1 equals 4d, which means d equals also 1/4. Okay, now let's make t equals 0. How do I come up with these numbers? Just the positive and negative 1 are very clear, but I need 2 more because I need 4 equations and I only have 2 equations. So I chose a simple number like 0. Okay, let's see what we get with 0. 1 on the left-hand side. 0, so this is 1. 0, and this is 1 because it's squared. So that's just a. 0 is negative 1, but squared, so plus b. 0, it's 1 squared. 0 minus 1, so this is negative c. And 0 plus 1 is 1, so plus d. Okay, so I know that this is 1/4, and I know that this is 1/4. 1/4 plus 1/4 is 1/2, subtracted from 1, so I have 1/2 equals a minus c. I need one more equation. So let's say t equals, I don't know, 2. So let's see what we get with 2. 2 plus 1 is 3. 2 minus 1 is 1. So 3a. 1 equals 3a. 2 minus 1 is 1, so plus b. 2 minus 1 is 1, so 2 plus 1 is 3. 3 squared is 9. Did I square here? No, it was not needed. Okay, 9 plus 9c. So again, I'm doing 2 plus 1, so this is 3. 2 minus 1 is 1. 2 minus 1 is 1. 2 plus 1 is 3 squared is 9, and this is 1. And here I have 2 plus 1 is 3 squared, so plus 9, 9d. Okay, so let's see next. Again, b is 1/4. D is 1/4. 1/4 plus 9/4 is 10/4. So 10/4 is 5/2. 1 minus 5, because I have to bring it here. 1 minus 5/2 is negative 3/2. 1 minus 5/2. Negative 3/2, correct. Okay, equals 3a plus 9c. We're going to pair it with this. 1/2 equals a minus c. So I would like to eliminate maybe c, so I'll multiply the second equation both sides by 9. So negative 3/2 equals 3a plus 9c. 9/2 equals 9a minus 9c. I add the fractions now. Here I have 12a, and here 9 minus 3 is 6. 6 divided by 2 is 3. So then a equals 3 over 12, or 1/4. If a is 1/4, I can determine c. So 1/2 equals 1/4 minus c. 1/2 minus 1/4 is 1/4. So 1/4 equals negative c, so c equals negative 1/4. Gee whiz, we finally finished determining these coefficients. Okay, so Okay, page 8. I'm just gonna write the inequality, the integral from the beginning. So dt t plus 1 squared t minus 1 squared equals. We had a over t plus 1. A is 1/4. So 1/4 the integral from 1 over t plus 1 dt. B was 1/4 plus 1/4 the integral from, and it was t plus 1 squared. So 1 over t plus 1 squared dt. We're moving on to c, but c is negative 1/4. So negative 1/4 the integral from, c had in the denominator t minus 1. So 1 over t minus 1 dt. And finally, d was also 1/4, so plus 1/4 the integral from dt over t minus 1 squared. Okay. Very good. So let's finalize this. Okay. So the first one is 1/4 natural log of the absolute value of t plus 1. Obviously, this one is negative 1/4 natural log of the absolute value of t minus 1. This one is negative 1/4 of 1 over t plus 1. And this one is negative 1/4, 1 over t minus 1 plus a constant c. I hope this helps you. Thank you.